Oh, if someone wants to shut the blinds, if that.
Who keeps opening them?
After the first period, it's good to have the windows open.
What?
I like having the windows open after first period.
Why?
Because I like to be able to see outside. Thank you. So now we're going to work first with polyatomic ions. If you look at your little ion chart in the box above the periodic table, those are the polyatomic ions. Poly means more than one, so we have more than one atom in the ion. So far we've looked at monatomic ions where it's just calcium or just sodium, just sulfide. Now we're going to be mixing two atoms together. They're covalently bonded together, but overall they have a charge. So they're called oxyanions, a lot of them, because they have oxygen in their polyatomic ion. And there's a pattern. If you look at chlorate on your chart, you'd see chlorate is ClO3 with a -1 charge. I think in that chart they're alphabetical. So chlorate has ClO3. If you take away, if you have one less oxygen, so it would be ClO2. That is now chlorite. So it's changed to an ITE ending with taking away an oxygen. If you take away another oxygen, you change it to a hypochlorite. You've added a prefix hypo, use the suffix ITE, and you have ClO -1. Now if you take the chlorate, the ClO -1, and add an oxygen, then you're going to add the prefix per. So perchlorate. The microphone. Now when we're going to have quizzes over these polyatomic ions also. So I would say chlorate, and you'd have to tell me ClO3 -1. But there's not really, well, chlorate is ClO3, so there's 3 oxygens. Nitrate is NO3 with 3 oxygens. Sulfate is SO4 with 4 oxygens. So just because it has an ATE ending does not mean you have 3 oxygens automatically. So you have to remember whether it has 3 or 4. There's no special naming of anything that we need to do with these. You don't have to change stuff, the endings or anything. We just use the whole name. So if we write the formula for tin for sulfate, tin we know would be SN with what charge? 4+, so we'd have SN4+. Now you're going to have to look up sulfate. It's not sulfide, it's sulfate. What is sulfate? 2-. So what is going to be our formula? How many sulfates do we need to balance out that tin? If we have a 4+ charge and a 2- charge, we need 2 sulfates. Or when we cross them over, you'll see there's a 2 and a 4 that we crossed over. We can reduce all those by 2. So we would have SN, and then we'd have SO4, because you cannot change this number. This is telling us how many oxygens are in the polyatomic ion. We cannot change that 4, but we do need to cross over. We have 2 of these, so I'd want to put a 2 here. Now, if I just put the 2 like that, does it look like that I have 2 sulfates or 42 oxygens? So we need to put parentheses around the sulfate to show that we have 2 sulfates, not 42 oxygens.
How do you not get 2 sulfates? Just you took 4 minus 2.
The 4+, does that balance out with 2-? So if I add another, if I have 2 sulfates, then I'd have 2- and 2-, which is 4-. 4- balances the 4+.
That's 4 minus 2. Why would you put an SN4 SO4 2? Come on, Dave.
So I mean this SN2
Yeah.
SO4 4? That?
Well, that's SN4, right?
Yeah?
And then SN SO2.
Yes, you need 2 sulfates.
I know, but in the equation SnSO4 2, how do you know there's 4 SNs like it says up there?
No, there's only 1 SN. But that 1 SN has a 4 plus charge. That 4 doesn't say that there's 4 tins. Okay, how about lithium nitrate? Lithium. Take a step back here before I forget. If you do just cross charges, you would have written this down. This. And when you reduce it, you can't reduce this 4. This sulfate is not reducible. You're reducing just what you crossed over, and you just crossed over the 2 and the 4, so you would only reduce this 2 and the 4. You don't have to worry about reducing anything from the polyatomic ion. Okay. So back to the lithium nitrate. What is nitrate? -1. So what's our formula? Yep. No. Since we aren't bringing a subscript down behind the nitrate, we don't have to put parentheses around nitrate. So we just have LiNO3. How about sodium carbonate? Oh wait, yep. Copper 2 sulfate. Never mind. Copper 2 sulfate. Copper 2 plus. So how many of each do we need to balance the charges? Right, we just need 1 of each, right? The 2 plus and the 2 minus balance each other. So we can just have in sulfate. Sodium carbonate. It's Na plus. What's carbonate? So do these balance each other out? No, a +1 and a -2 do not balance each other out. How many sodiums do we need? 2. So we would have Na2CO3. Now this time we don't have to put parentheses around this one either because we aren't putting a subscript outside of the nitrate or the carbonate. Calcium nitrite. Calcium is 2 plus. What about nitrite? NO2 minus, right. ITE ending, not ATE. And it's ITE, not IDE. Those sound very similar. Nitrite and nitride sound very similar, but they're different ions. So what's our formula? In parentheses, yep, 2. Because we have to have 2 nitrites in order to balance out the calcium. What? Can I switch it? Like NO4? Because you can't change nitrite. Nitrite is NO2 always. And plus, if you just put NO4, you've just added oxygens to it and no nitrogens either. You've changed that polyatomic ion. Okay, and then potassium perchlorate. So potassium is K plus. What's perchlorate? -1. So how many of each do we need to balance each other out? Just 1. So we'd have KClO4. Yes. Questions on writing the formulas using polyatomic ions here? We'll go to naming some here in a little bit. Okay. So now we're going to give the names. So calcium hydroxide. I gave you the answer. If you look for OH in your chart.
Yep, right there.
What's the name of it? Hydroxide, yep. Now we do have to worry about Roman numerals. So does calcium need Roman numerals? No. So it's just calcium hydroxide. There's one positive polyatomic ion. Because all the polyatomics will be anions, there's one cation. And that's ammonium. If you look at, it's at, oh, I guess your chart has two. We won't use hydronium. At the very bottom right corner, it has the positive polyatomic ions. So ammonium's the only one that'll be positive. So KClO3,
Potassium hypochlorite.
Perchlorate is ClO4. This is ClO3. So if you come across this ATE, if you come across this on a worksheet and you don't know whether or not it's a polyatomic ion or not, it's not potassium chlorine oxide, trioxide or something weird. Okay. Why is it not hypochlorite? Hypochlorite is ClO. And this is ClO3. The 3 did not come from the charge. That is one thing. Because maybe the 3 did not come from this charge because K is just K+. And if that 3 came from the charge, there should be parentheses around it. But there's not. Whoa. But if you came across this on a worksheet and you didn't know whether or not it's a polyatomic ion or not, remember that the only positive polyatomic ion is NH4. So since this is just K, this is your cation, which means all the rest of this has to be an anion, which would be polyatomic ion. So you'd look at your chart on that table. Okay, how about this next one? Right, this is one where NH4 is that positive ion that we have. So ammonium, what? Hydroxide. Hydrogen peroxide. FeCrO4. NH4. Yep. Okay. Oh, it's iron. Iron can form a 2+ or 3+. So we need to indicate which one it is. So what charge did chromate have? A 2-. So iron must have been a 2+. So it would be iron 2 chromate. And this last one, so this is one where we use hypochlorite. Because the ClO has no subscripts, that is hypochlorite. Okay, so far, we've done all ionic compounds where we have a cation and an anion. And those are the naming rules for ionic compounds. Now we're going to go to molecular compounds. So molecular compounds mean they're using covalent bonds. So far we've looked at ionic bonding. This will be covalent bonds that are formed between atoms. So in order to determine whether or not it's a molecular or ionic bond, there's a couple different ways we can look at it. The most in-depth way is probably look at your electronegativity chart, subtract the two numbers, determine what type of bond it would be. If it's a covalent bond, you'll use the molecular compound naming system. Or if you just look at your ion chart, if they are both negatively charged, if the two ions or the two elements that are in the compound are both negatively charged on your periodic table of ions, then it's going to be a molecular compound. You do not use the ionic compound naming system. You'll use the molecular compound naming system. So you can either use the stock system, which we'll get to later. We're not going to deal with the stock system. You can use Roman numerals again. We are going to learn the prefix system, where you're going to use prefix to tell you how many of each atom there is in that compound. And remember, this is only for molecular compounds. So for this, if you looked up carbon and chlorine, carbon doesn't have a charge on your chart, and chlorine has a negative charge. Carbon, though, is a nonmetal. So if two nonmetals are bonded together, it will be a molecular compound. So we would use the prefixes. So carbon, tetra means 4. So there would be carbon with tetrachloride because there's 4 chlorines there. Carbon monoxide, there's only 1 oxygen. Carbon dioxide has 2 oxygens. So those are all molecular compounds. So what are the prefixes for the numbers? So if you had 1, what would be your prefix? Mono. 2? 3? Tri. 4? Tetra. 5? I think I heard someone say it up here. Penta, yes. About 6. Hexa. 7. Hepta, yes. 8. Octa. 9. Nope. Nona. Nona.
How do you spell that?
N-O-N-A. And then 10 would be?
DS.
What? Deca. Yep. So here's all those prefixes. You knew most of them already. So get those written in here. Yeah, well, vowels don't have the, we'll go over that. Can I change it?
No.
You already talked about all these.
A little slow. He didn't understand that we were saying everything. I didn't understand that they were on the paper. Okay, I was in the zone.
You know what? I think we'll go over these rules tomorrow because we don't have a whole lot of time left, and I'll give you. Okay, so this worksheet